All right, continuing on with geometric sequences, given this following example with algebraic expressions, it says x is our first x plus 5, x plus 9 are the first three terms in this geometric sequence. Determine the exact value of each term. Well, in order to figure out the exact value, I first need to figure out, well, what is the value of x? How do I figure that out? Okay, so thinking about this geometric sequence, this is our first term, second term, and this is our third term. And thinking about similarly to arithmetic sequences, to get from the first term to the second term, we need to multiply this by a common ratio. Same as going from the second term to the third term, we also need to multiply this common ratio. So in order to figure out the common ratio, if I take my second term and I divide it by my first term, this will give me my common ratio. As well as if I take my third term and I divide it by my second term, this will also give me my common ratio. So if these two expressions are both equal to r, technically what I've done is created a system of equations here. These are both equal to my r value. I'm going to replace this with r here. And so if I take my second term, divide it by my first term, this is equivalent to my third term divided by my second term. All right, so now I'm going to substitute in these algebraic expressions for each of these. My second term is x plus 5 over x. My third term is x plus 9 over x plus 5. All right, so in order to solve for x here, what we want to do is remove this fraction by simply cross multiplying. So we're going to cross multiply my x plus 5 times x plus 5. And I'm going to put that in brackets because they're both binomial. And then I'm going to multiply my x times an x plus 9. And so what that does is removes the fraction in the denominator. So in order to solve this equation, what we need to do is we need to expand this. So this is our distributive property. So if you can remember from last year, how do I distribute that? I'm going to use FOIL, first times first, which is x squared, outside times outside, which is plus 5x, inside times inside is another 5x, last times last is plus 25. And then this is going to be equal to, I'm going to distribute this through my brackets as well, x times x is x squared, x times 9 is 9x. Okay. So now what I want to do is I want to solve this equation. Well, to solve this equation, I need to first simplify this side. So I have an x squared plus 10x plus 25 equals x squared plus 9x. So what we'd like to do when we solve these things is we want to move our x's to one side of the equation. Okay, so let's suppose we move these to this side. So if I want to move this x squared to over here, I'm going to subtract an x squared from both sides. So those are going to cancel. But look what also happens over here. This x squared is also going to cancel. So those basically disappear. They cancel each other out. So now what I'm left with is just a 10x plus 25 equals 9x. If I move the 10x to this side, I need to subtract 10x. I'm left with 25 is equal to 9 minus 10x, which would be a negative 1x. And then to solve this, I am going to divide by a negative 1. So my x value works out to be a negative 25. Okay. So determine the exact value of each term. So let's go back to these expressions. My first term of the sequence would be x, which is negative 25. My second term of the sequence, I want to add 5 to that, so it would be negative 20. And my third term to that, I'd want to add 9 to that sequence, which would be negative 16. So my first three terms of this geometric sequence would be negative 25, negative 20, and negative 16.